In today's video, we're going to walk through a bit of a tutorial on how to build an API. In this example, I'm going to be using Python along with a library called FastAPI to quickly create an API that allows us to provide a kiosk on the front end of a restaurant where a customer can come in, log in by selecting their table number. They can then see a menu of available items. They can add those items to their order. They can then place their order and then monitor the status of their order as it's going through the various stages of being prepared by the kitchen. This is to demonstrate how an API works between a front end and a back end. We're also going to be using UVcorn as our Python server so that we can allow our APIs to be accessed by the front end. So let's check it out.
This is Rossi Bytes.
Welcome to Bella Vista. Throughout this tutorial, I will be using a restaurant analogy to help simplify the concepts we'll be covering. At the moment, the restaurant is just an empty concept with no functionality. Before we start cooking, we need to set up our kitchen properly. Just like a restaurant needs its own space with specific tools and ingredients, our Python project needs its own isolated environment. We call this a virtual environment. Think of it as setting up a pop-up restaurant with exactly the supplies we need, separate from everything else on our computer. This first command is basically creating our environment or our pop-up kitchen in our restaurant. Next, we're going to activate our environment, which is like physically entering our kitchen space. Finally, we're going to install some required packages or equip our kitchen with the tools that we're going to need to cook. From within our environment, let's go ahead and create a new file. In this case, I'll call this food.py. This is a Python file. Let's start with the absolute basics. A restaurant that can only tell you that it's open. This is like having a simple "we're open for business" sign. So here's what's happening. The first line, from FastAPI, import FastAPI, is like hiring our waitstaff system. App equals FastAPI creates our restaurant. The @app.get part is like telling our waitstaff that when a customer walks in and asks if we're open, here's what we want you to say. The def health defines exactly what our waitstaff should do. In this case, return a message saying that we're open and ready for business. Next, I'm going to go ahead and change directory into my restaurant, and I'm going to go ahead and use UVcorn to start up my server. UVcorn is one of the packages that we installed at the beginning of this process. Upon running, we're going to see that we're given an address that we can browse to with our browser. So upon browsing to our server, this would be like walking into the restaurant and asking if they're open. As you can see, we're getting the response back that we expected. One of the nice things about using FastAPI with Python is that it generates Swagger documentation so that you understand what APIs you have and how to use them. As we can see here, this is our getStatus API. Now that our restaurant is open, we need to create our menu, which is going to be what the customers can order. So I'm going to go ahead and add in 4 different dishes here. Now that we've created our menu, we have to train our waitstaff on how to hand over the menu to the customers when they ask what they can order for meals. So as we can see, this would be the app.get/menu is the same as if a customer asks the waitstaff what's available to order. And the response for that is going to be the menu list that we just created. Upon saving our changes, if we browse over to /menu, you'll see that we're getting back our menu list. One of the tools available with FastAPI is HTTP exception. This is like teaching our waitstaff to politely handle problems. For example, if a customer orders something that's not on the menu, instead of just crashing on them, they'll give a proper error message back letting them know that that item is not available. Next, we're going to install a tool from Pydantic. Think of this like creating standardized order forms. In a real restaurant, you might have a particular format that you take orders in. For example, the table number, maybe the party name, and then all of the items that they order. Pydantic helps us define exactly what information we expect and then automatically validates it for us. Next, from typing, we're going to install list and optional. These are like describing what type of information goes into each box on our order form. List, as a string, for example, means a list of text items like multiple food items. And optional, which is an integer, means a number that might or might not be provided. For example, a table number. And finally, from UUID, this is going to generate a unique order number automatically. Like those order dispensers that you see at the delis, for example, every customer gets a completely unique ID, and it will never be repeated, even if you have millions of customers. So here's where we start to get fancy and start adding in some logic. The order in class is like the format of an order ticket. It defines exactly what information we need from our customers, such as the items they're ordering, and then optionally what table they're at. Order out is like their receipt showing their order number and status. We've also created a dictionary to keep track of all the orders. We've also defined a new route, and this is using a post to orders. This is basically our wait staff is checking to see if everything that has been ordered is actually on the menu, just like they would in a real restaurant. If they order something we don't have, we politely tell them what's wrong. However, if everything looks good, we go ahead and generate a unique order number using UUID4. Think of this like those tickets that you get at the deli. It's unique to you. We then call to order out to create the receipt for the customer so that they can keep track of their order. We then store their order in our orders dictionary, which is like a ticket rail in the kitchen where we keep track of all the orders we're working on. Now that we've created our order taking system, let's go out to our Swagger documentation and look up the API for this. We'll see the Post Orders API, and we can click to try it out. Underneath items, I'm going to replace the string value with one of the food items that are part of our menu. In this case, I'll do the margarita pizza and a Caesar salad. And then underneath table number, I'm going to put in table number 5. And I'll go ahead and click execute. And then we'll go down and see the response that we got back is our order ID, that it's in a status of received, the items that I ordered, and what table I'm a part of. Next, we're going to test with the same API a menu item that is not available on our menu. In this case, filet mignon. We'll then go ahead and click execute, and then if we look at the response, it says, sorry, we don't have filet mignon, check our menu. So our error handling is working properly. Next, we've added a new route that allows us to look up our order by the order ID. As you can see here, we're going to do a GET call from the Orders API, passing in our order ID as a parameter. If the order isn't found, we're going to return back a message, order not found. So if we come back out to our Swagger UI here and we go underneath Post Orders, we're going to create a new order. So I'll go ahead and put in a menu item underneath the items. And I'll also put in a table number of 6. I'll click execute. And then if we scroll down and look at the response, we can see our order ID. So I'm going to go ahead and copy that to my clipboard. And then I'm going to scroll back up and I'm going to use the new Get Orders by Order ID API. And I'm going to paste in my order ID and click execute. And if we scroll down, we can see that our order is in a status of received. At this point, we have the ability to place orders, but they're going to the kitchen and just sitting in a status of received. So let's go ahead and add in our actual kitchen so that they can start preparing and cooking the food. Before we can do this, however, I have to install a few additional tools that are going to be needed within our code. One of the most important ones is async IO. This is going to essentially allow the kitchen to work on orders, but not hold up the wait staff so that they can then go ahead and take more orders from other customers. The first thing we need to do is we need to provide more specificity to our orders ticket rail. Previously, we just had an empty rail that anything could be pinned to, so imagine people pinning a napkin to it, for example. But what we're doing now is we're providing it some type hints or more of a context as to what is allowed on the ticket rail itself. Additionally, under our order out class, I've added in a meal line. And what this will do is it will represent the finished plated dishes that are ready to serve. Underneath our order tracking system, I've created this async def cook function, which is our kitchen. It works in the background while our staff continues serving other customers. The async and await words are like saying, this takes time, so don't just stand there waiting, go help other customers while the food cooks. I've also added in some functionality to the post API so that when the wait staff takes an order, they immediately hand it off to the kitchen using the background tasks, and they send that background task to the cook. This is similar to clipping the order to the rail of the kitchen. The kitchen then goes through the cooking process. I've also added in a new route that allows us to cancel the order. But like any real restaurant, you can't cancel an order once the kitchen has started cooking it. So the delete method will let customers cancel orders, but only if they're still in the received status. If they've gone past received, then they cannot cancel it. If the order is successfully deleted, it will set the status of that order to canceled. So let's walk through end to end the actual kitchen cooking process. So right out of the gate, we're going to wait for 10 seconds, and this is going to simulate prep time, for example. We're then going to check the order, and if the order is in a status of canceled, we're not going to process it. However, if it isn't, we're going to go ahead and move it to the status of preparing. Then, to simulate the cooking process, we've added in another 10-second delay here. And what this is going to do is allow for the food to be cooked. Once the meal is completed and plated, it's going to return back the information about which items have been plated for that particular order and are ready to then bring back to the customer's table. So now to bring everything together, I've used AI to generate a React-based front end, and I'm going to go ahead and select my table number and click Start Ordering. It's then going to call out to the Menus API endpoint and bring back all of the valid products that we can add to our order. And I'm going to add a few items to the order, and then I'm going to go ahead and click to review my order. Then I'm going to go ahead and click Place Order. And we'll see here that I have the option to cancel the order. And I've gone ahead and canceled the order, so that API is working correctly. So we're going to go ahead and place another order. We'll add a few items to the order itself. We'll then review the order. And we'll go ahead and place our order. So then we're going to see it go through the various stages, starting with received, that 10-second delay. Now it's being cooked. It's in the preparing status. And after the other 10-second delay that we built into the code, it will then be ready and completed. And we can see which items have been plated and are ready for service to the customer's table. And then if we go ahead and take a look at the logs on the back end, we can see the get menu request. We can also see the first order that was placed. We can see that we deleted that first order. And then we went back and created a new order. And the last order number you see is the one that went through all the stages and was brought back to the customer's table. So as you can see, using Python, FastAPI, and Uvicorn, I was able to quickly and fairly easily create a basic API that allows you to do a variety of different things in a real-world scenario. I will include links to the source code for both the backend server and API, as well as the front-end code that I created as well. I hope you found this content useful. Please click like and subscribe, share with your friends, and have a great day.